Module 4, Session 3. Session 3 will cover Part 2 of Learning Outcomes 3.3.1, 3.3.2, and 3.3.3, using compound and double angle identities. Learning Outcome 3.3.1, 3.3.2, and 3.3.3, using compound and double angle identities, Part 2. Now we are going to look at double angle identities. This is also brand new work for students. A double angle is an angle for which you multiply the angle by 2 before you find the trigonometric ratio. For example, sine 2 theta. The double angle identities are derived from the compound angle identities, and they have further useful applications. Students don't need to know the derivations of the formulae. Let's take a look at our double angle identities. There is one identity for sine 2 alpha. Sine 2 alpha equals 2 sine alpha multiplied by cos alpha, and 3 different identities for cos 2 alpha. Cos 2 alpha equals cos squared alpha minus sine squared alpha. Cos 2 alpha equals 2 cos squared alpha minus 1, and cos 2 alpha equals 1 minus 2 sine squared alpha. The double angle identities are numbers 12 to 15 on the exam formula sheet. Let's watch a lecturer applying the double angle identities in some examples.
Simplify sine of 120 degrees without using a calculator. Without using a calculator means that we need to use a diagram. So, first of all, we can say sine of 120 degrees is equal to sine of 60 degrees plus 60 degrees. That is exactly equal to sine of 2 times 60 degrees. And according to my formula sheet, I've expressed 120 degrees as a double angle. And when I consider my formula sheet, formula number 13, that is exactly equal to 2 sine 60 degrees cos 60 degrees. I am not allowed to use a calculator, so now I'm going to draw the sketch for 60 degrees. There's the 60 degrees. That is 2, that's 1, and that is square root of 3. And then obviously my famous mnemonics, saw and car. And now I'm just going to substitute 2 bracket for sine 60 degrees, bracket for cos 60 degrees, 60 degrees sine, opposite square root 3 over hypotenuse 2. Cos of 60 degrees adjacent over hypotenuse. And you will agree with me, we got an answer of 2 square root 3 over 4, which is equal to square root 3 over 2. Here we have another proof. Sine of brackets 45 degrees plus theta multiply with sine 45 degrees minus theta is equal to a half cos 2 theta. As it is the case with all proofs, we will always start at our left-hand side. And now once again I'm going to start straight away with the expansion of sine in both instances. Sine of 45 plus theta, according to my formula sheet, formula number 10, will become sine 45 cos theta. Very important to put it in brackets because we multiply, plus sine theta cos 45. That is the first one. For sine, the signs remains the same, and then the second one, sine 45 cos theta minus sine theta cos of 45. We close. Now here once again we can remove the brackets, or we can find the value of sine 45 with the aid of the diagram. It's going to give me 1, 1, and the square root of 2. Now I'm going to substitute the values of sine 45 and cos 45. This will give me 1 over the square root of 2, because that is what sine 45 is equivalent to. Cos of theta plus, what is cos of 45? Adjacent over hypotenuse, 1 over the square root of 2 sine theta. In this instance, exactly the same, 1 over the square root of 2 cos theta minus 1 over the square root of 2 sine theta. And if we look here, you will see the first terms and the second terms are the same, but it is a plus and a minus, which brings us to this very important mathematical concept. A plus b and a minus b will become a squared that is a squared minus, obviously, b squared. I will just note it down here so that we can see the difference. A plus b and then a minus b is exactly the same as a squared minus b squared, because that is what that is all about. And now what does this give you? 1 over 2 cos squared theta minus 1 over 2 sine squared theta. Now what is very important? Now I'm here, you get stuck. Now you look at your right hand side. I need a half. I have already got a half cos 2 theta. So now I'm going to take out a half as a common factor. Cos squared theta minus sine squared theta. And this is equal to a half. And what is cos squared theta minus sine squared theta? Don't need to dream about it. You go to your formula sheet, you look at formula number 14, and then you will see there cos squared theta minus sine squared theta is exactly equal to cos 2 theta. Therefore, left hand side is equal to right hand side.
Teaching tip. Students really struggle to recognize when to apply the double angle identities. Students need to be reminded that these identity equations work both directions. How do we know which of the 3 identities to use for cos 2 theta for proving identities? One way is to look at what else we have been given in the equation. If there is another sign in the equation, express cos 2 theta in terms of sign. In other words, cos 2 theta equals 1 minus 2 sine squared theta. If there is another cos in the equation, express cos 2 theta in terms of cos. In other words, cos 2 theta equals 2 cos squared theta minus 1. If there is both another sine and another cos, express cos 2 theta in terms of both. In other words, cos 2 theta equals cos squared theta minus sine squared theta. Try out this teaching tip with another double angle problem. Does it work for you? Prove that 1 minus cos 2 alpha divided by sine 2 alpha equals tan alpha. Work in pairs to do this activity. Here's the solution to the problem. Prove that 1 minus cos 2 alpha divided by sine 2 alpha equals tan alpha. We'll start with the left-hand side. We know that sine 2 alpha expands to 2 sine alpha multiplied by cos alpha. This means that our expression contains both sine and cos. So, it makes sense for us to express cos 2 alpha in terms of both sine and cosine. Our right-hand side is tan alpha, and we know from our quotient identity that tan alpha equals sine alpha over cos alpha. This is another clue telling us to express the double angles in terms of both sine and cos. So, the next line equals 1 minus cos squared alpha minus sine squared alpha all over 2 sine alpha multiplied by cos alpha. We multiply out the minus sign on the outside of the bracket on the numerator to get 1 minus cos squared alpha plus sine squared alpha all over 2 sine alpha multiplied by cos alpha. We know that our square identity says that sine squared alpha plus cos squared alpha equals 1. So we substitute sine squared alpha in for 1 minus cos squared alpha on the numerator. Adding like terms, we get 2 sine squared alpha divided by 2 sine alpha multiplied by cos alpha. We can divide top and bottom by 2 sine alpha, which leaves us with sine alpha over cos alpha, which equals tan alpha, which equals our right-hand side. We have successfully proved the expression. Work in groups to do this activity. There are 3 expressions to prove. Think about ways to make these types of problems easier for your students as you work through the steps. Here are the solutions to this activity worked through by a lecturer.
Let's look at the following example. Prove that cos 3x is equal to 4 cos to the power 3x minus 3 cos x. We need to prove that the left-hand side is equal to the right-hand side. That's why we will first start by writing down left-hand side. Cos 3x. We're going to express this as a compound angle. We're going to use 3x and express it as a compound angle by adding 2x plus 1x. And we can see there that 2x plus 1x is equal to 3x. Then we're going to go to our formula sheet, formula number 11, and then we're going to now expand this compound equivalent. And that will give us cos 2x cos x minus sine 2x sine x. Remember what I said earlier on, whenever we do proofs, as you move towards proving the proof, look at your right-hand side. Now, cos 2x can be expressed in 3 different ways. And those three formulas you will see on your formula sheets, formula number 14, where you can either use cos 2x and express it as cos squared x minus sine squared x, or you can express cos 2x as 1 minus 2 sine squared x, or you can express cos 2x equals as 2 cos squared x minus 1. But for this specific one, you will be guided by your right-hand side. And if we look at our right-hand side, you will see you only have cos's on the right-hand side. That is why the best option to use here will be cos 2x equals to 2 cos squared x, because we need cos's on the right-hand side. So we're going to select the option of 2 cos squared x minus 1. I think, people, we need to note that. Otherwise, we're going to move around in circle if we haven't select the correct choice. Cos x. And then sine double angle 2x from your formula sheet, formula number 13, that is equal to 2 sine x cos x. And obviously, that is multiplied with that sine x. Right. So now let's continue. Let's remove the brackets here. We have a monomial multiplied with a binomial. You're going to get 2 cos cube x minus cos x minus here. You will see here you have 2 cos x. I will do this additional step. Sin x times sin x give you sine squared x. Can you people see we already get to cos cube? We already get to cos cube. So we are moving towards the right-hand side. The next step here is cos 2x. We're going to now express that squared identity equivalent in terms of cos. 2 cos cube x minus cos x minus 2 cos x. And if you look at your formula sheet, formula number 7, the squared identity for sine squared x will be 1 minus cos squared x. Next step is, we will now remove the brackets. 2 cos cube x minus cos x. Again, a monomial times a binomial. Minus 2, that gives you minus 2 cos x. Take note, a minus and a minus gives you a plus 2. Cos to the power 1x times cos to the power 2x, that gives you cos to the power 3x. And your last step is now, we will now add the like terms. 2 cos cube x and another 2 cos cube x, that gives me 4 cos cube x. A minus 1 cos x and a minus 2 cos x, that gives me minus 3 cos x. Therefore, our left-hand side is equal to our right-hand side. Let's look at this proof. Prove that sine 2x divided by 1 plus cos 2x equals to 10x. Once again, we start with our left-hand side. Sine 2x, I will write it down and then simplify it. Sine 2x, 1 plus cos 2x. This is equal to, according to my formula sheet, sine 2x, the double angle. If you look at formula number 13, it will give you 2 sine x cos x plus 1 plus juice. Cos 2x, my formula sheet gives me 3 formulas. Cos squared x minus sine squared x, 1 minus 2 sine squared x, 2 cos squared x minus 1. Whoo! Now I need to look at my right-hand side. Even worse, my right-hand side gives me 10x. But if I look at formula number 5, then I will see there that 10x is equal to sine x over cos x. In other words, I already have sine x on top. I need to cancel out that cos x. And that's why the best option to use here will be formula number 16. 2 cos x, 2 cos squared x minus 1. Because 10x means sine x over cos x according to formula number 5. And now we're just going to simplify. You have 2 sine x cos x over 1 minus 1 cancel out. You have 2 cos squared x. And now you're going to simplify. 2 and 2 will cancel out. Sine will remain on top. There's a cos 1 and a cos 2 at the bottom, which means cos will remain at the bottom. And this is exactly equal, according to formula number 5, equal to 10x. Therefore, left-hand side is equal to right-hand side. We are having here another proof. Proof that cos 2x double angle plus cos x minus the square root of 1 minus sine squared x plus 1 equals to 2 cos squared x. Let's start once again with our left-hand side. I think you people from the other two supposed to pick up now what's going to happen here. I need to express cos 2x in terms of cos because my right-hand side tells me that I need cos squared x, which means I'm going to go straight to formula number 16, which is 2 cos squared x minus 1 plus the cos x minus. Now, square root. People, if you look on your formula sheet, formula number 7. Let's write down formula number 7 and see, can't we design something that's equivalent to that thing that looks so strange? Right? Formula number 7, sine squared. I'm going to write it in terms of x plus cos squared x is equal to 1. Right. Now, cos squared x is equal to 1 minus sine squared x. Therefore, cos x is equal to the square root of 1 minus sine squared x. I've just proved now that the square root of 1 minus sine squared x is equal to cos x. So I can say there clearly now minus cos x plus 1. And then straight away, people, isn't this a nice problem? A minus 1 and a plus 1 cancel out, a cos x and a minus cos x cancel out. 2 steps. 2 cos squared x. Therefore, left-hand side is equal to right-hand side. Please Don't allow the examiner to John Cena you with square roots.
That brings us to the end of this module. In the next module, we'll be looking at solving trig equations in the range 0 to 360 degrees and solving problems in 2D and 3D using the sine and cosine rules.